So, learning objective 2F, the syllabus dictates that you need to deduce from the shape of a distance time graph when a body is in at rest, moving at uniform speed and moving at non-uniform speed. So you need to be able to tell these three things from a distance time graph. So let's look at this question that was tested in 2 years, 2005, 2008. And I'm sure, similar variations are tested every year, okay? So in a distance time graph, obviously this axis tells you the distance, right? This axis tells you the distance, this axis tells you the time. So if, for example, let's say this is like 5 seconds and this is like 10 meters. I ask you to, 10, right? 10 meters, this is 5 seconds. And ask you to state the time taken to travel 10 meters, right? So this graph just tells you, you read off the graph, right? If you're looking at distance, then this tells you exactly when the distance is traveled. With the distance traveled, this tells you the time. So it takes 5 seconds to travel 10 meters, something like that, right? So in the distance time graph, you read off the distance directly. What does the gradient of a distance time graph tell you? What does the gradient of a distance time graph tell you? So the gradient of a distance time graph, dt graph, always gives you, so gradient means what? The rate of change, right? So gradient is always looking at the rate of change. So it's the rate of change of distance. And as you would have seen in the previous video, or you would have already known if you got the question correct, rate of change of distance is simply known as the speed, right? Another way of looking at it is a gradient measures how fast a quantity is changing, right? So a gradient is the slope, is the steepness of a slope. It measures how fast the quantity is changing, how fast is distance changing over time. So how fast distance changes over time is also speed. Okay, so this is what you need to know, that the gradient represents speed. So now that you know the gradient represents speed, how do you know at which position is what? Okay, so if you look at the gradient, let's say we have a couple of things we need to do here. So when is it at rest? Okay, so you basically just ask yourself, when is the gradient 0? Okay, so here the gradient is 0. That means that there is no speed because the gradient represents the speed, right? So when it's horizontal, so this is when it is horizontal. Basically, gradient equals to 0. Okay, when is it moving with uniform speed? So uniform speed means constant speed. You're looking at the gradient again, you're looking for constant gradient. And if you're looking for constant gradient, basically you're looking for where the steepness, so gradient is always referring to the steepness, right? So to break that down, gradient always means steepness. So the steepness, so it's constant steepness. Okay, where do you get constant steepness in this graph? Can you see that this region here is constant steepness? If you are walking from left to right, the steepness is constant. So this region here is constant steepness, is uniform speed. Okay, so gradient is constant. The last one, moving with non-uniform speed. So it's when the speed is changing. So non-uniform speed means speed is changing. Oops, maybe I'll zoom in a bit here. So this means that the gradient is changing. And gradient always means steepness. So steepness is changing. I'm breaking this down basically to make it more and less and less jargon, okay? So I'm sure you can recognize when the steepness is changing. As you walk from here to here, how is the steepness changing at the region X? Is it getting more and more steep or less and less steep? Okay, the key question to be asking yourself for these questions to identify non-uniform speed is it getting more and more steep or less and less steep? How is the steepness changing? Okay, ask yourself, how is the steepness changing to find out how is the speed changing. So in this case, the steepness is getting more and more steep as you go along, which means the gradient is getting faster, which means the speed is increasing, right? So non-uniform speed, the speed is increasing. What about this region here? As you walk from left to right, can you see that it's getting less and less steep? It's getting less and less tiring to climb this hill. So if it's less and less steep, that means that the gradient is decreasing, which means the speed is also decreasing. So less steep, less and less steep, so gradient decreasing, so speed decreasing. Okay, of course all of this explanation is overkill to answer this simple MCQ question, yeah, so let's look at MCQ question now. The graph shows how the distance traveled by a car changes with time. Which statement is correct? Okay, at X the car is not accelerating. Look at X. Okay, it is getting more and more steep, which means the speed is increasing, so it is accelerating, so this is wrong. At Y the car has uniform acceleration. Uniform acceleration means that it is getting faster and faster at a constant rate. But at Y, is it getting faster and faster? No, right? It is constant speed, because it is constant steepness, so constant gradient, so constant speed. So this is also wrong. At Z the car has uniform speed. Is that correct? That is correct, right? Because it is, oh, actually no, sorry, that is wrong. At Z, it is not uniform speed because there is no speed at all. It's horizontal, the gradient is 0, the steepness is 0, so the speed is 0. Right? So it's wrong. At Z, the car is at rest. The answer is D. Alright? So I hope we're very, very clear now with how to interpret a distance time graph, how to find the speed from a distance time graph. Okay?